Hello everyone. Now we are going to see about the time response analysis. In control system, the first unit covers the modeling of the system, then find the transfer function of the system using block diagram or signal flow graph. So using this transfer function of the system, next we are going to analyze the system in time domain method. So now the concept of time response analysis are coming from the upcoming slides. So, time response analysis is an important concept used to study how the system behave over the time. It is widely applied in biomedical engineering for analyzing signals and system outputs. This time response is mainly divided into transient response and steady state response. This presentation introduces key concepts, methods, applications. Then this explains how the system reacts to inputs over the time. It helps in understanding system stability and performance. This is crucial in biomedical signal processing and control systems. Examples like ECG signal response and medical device behavior. So in time response, we have two responses, that is transient response and steady state response. Based on these two responses, we are going to analyze the system. Here the graph shows that the output starts to produce from zero time to certain time. So from starting at zero time, it starts to get oscillate. After this certain time, it settles to stable state. So at the time of oscillations, is from one state to another state, that is called transient response. After the output comes to the stable state, it is called the steady state response. So formally, the transient response occurs immediately after input is applied. Then a steady state response represents long-term behavior of the system. Both are important for analyzing the system, the accuracy and stability. So in first order systems, it has simple response characterized by one constant. Then they are commonly used to model biological systems. The response gradually reaches the steady state value. Examples like temperature control and drug absorption models. So time response in first order system is too simple. So in second order systems, the second order system shows more complex behavior like oscillations. So this is analyzed based on the damping ratio and natural frequency, because the system is too complex. So when it starts to produce the output, it gets oscillations. To reduce the oscillations, we are giving the conditions like damping condition. So there is a parameter like damping ratio, which is the ratio of the actual damping to the critical damping. So based on the damping ratio, the system produces the output. So based on the damping ratio, the system is classified like undamped, then underdamped, then critical damped, overdamped. So based on the damping ratio value, the system may be classified into four types. Okay. Then natural frequency is producing before the damping conditions are given to the system. So to reduce the oscillations, we are giving the damping conditions. Based on the damping conditions, damping frequency will be produced. Okay. Then the underdamped system shows oscillations while overdamped system responds slowly. Okay, these are useful in modeling heart rate and physiological feedback systems. So based on these parameters, there are some time domain specifications for analyzing the second order system. That specifications are delay time, rise time, peak time, maximum peak overshoot, and setting time. These time domain specifications are shown in the graph clearly. So already we know that the output of the system produces starts to produce from zero time to certain time. So from zero time to that starts to zero time. So next, the half of the output produced at the time is called delay time. So when the maximum output is produced, the time is called rise time. So from the maximum output, then next to the maximum peak oscillations, that is called peak time. Then from maximum output to maximum oscillation is called peak overshoot, that is maximum peak overshoot. So after some oscillations, that is transient response, it settles to stable state. That time is called settling time. So that settling time has some tolerance value, that is due to percentage or 5 percentage. So these are the time domain specifications for second order systems. Based on the specifications, how the output is produced from the second order systems are analyzed. Okay, so this time response analysis is used in biomedical applications like ECG, EEG, and medical imaging systems. It helps in designing accurate and reliable biomedical instruments used in control systems like pacemakers and ventilators. It improves diagnosis and monitoring of patients. Especially time response analysis is essential for understanding system dynamics and also ensures stability and efficiency in biomedical systems. Both first order and second order responses are widely applied. This concept plays a key role in modern healthcare technologies. Thank you.